Hello everyone, welcome to my YouTube channel Chemistry Lover. So today in this video I have shown you another name reaction known as Reformatsky reaction. So for performing this reaction we need two different types of molecule. One is aldehyde and another is alpha haloester. Here you can see an ester group present and chlorine connected with the carbon present at alpha position with respect to the functional ester group. Here you can also use ketone in place of aldehyde. I have considered aldehyde in this case, but you guys also use ketone in place of aldehyde. Okay, so there is no restriction for this. And zinc dust is needed, followed by acidic workup. So finally we can obtain alpha beta unsaturated acid. You can see this is an alpha beta unsaturated acid. Here R can be alkyl or aryl group, anything. Now let us know the mechanism for this reaction. So first there is an organo-zinc compound formation take place. Here zinc atom coordinates with the oxygen of carbonyl group, and further the carbon-carbon pi bond formation take place and chlorine removing as a leaving group from the system. As a result, an organo-zinc compound take place. Here you can see this is an organo-zinc compound because the zinc coordinates with the oxygen and chlorine atom. Now this organo-zinc compound undergo nucleophilic attack on the another carbonyl group. Here I have written here this nucleophilic attack by the organo-zinc compound on the carbonyl center of aldehyde. Here this pi bond actually take place, or you can see added on the carbonyl group, and the carbon oxygen double bond break, and here this is an adduct is obtained. Now it takes place via the formation of a 6-member stable transition stage, which is shown here, right? Here you can see closely, this is a 6-member stable transition stage because here the pi bond breaks and here the bond formation take place, and the zinc coordinates with the two oxygen atom, and the bond breaking bond formation I have seen here by the dotted line. So this is the 6-member stable cyclic transition stage, and the reaction proceeds via this stable transition stage. So this step you can see the rate determining step, or RDS. That's the nucleophilic attack of the organo-zinc compound or on the aldehyde or ketone, and ultimately this species is obtained and it is hydrolysis and give us this is beta hydroxy ester, because this OZNCl group converted into OH in presence of aqueous medium. And again if we heat the molecule, then alpha beta unsaturated ester is obtained, and finally through hydrolysis the ester group converted into acid, and we can obtain our final alpha beta unsaturated acid. So this is the entire mechanism of this reaction. You can see that first step is the formation of organo-zinc compound, because zinc added here and it reacts as a metal ion and it coordinates with the oxygen of carbonyl group. Hence here an organo-zinc compound formation take place, which proceed the reaction further via nucleophilic attack, and finally we need to hydrolysis this species, and by heating the removal of water take place, and we can finally obtain our desired alpha beta unsaturated acid. Now there are several combination of reactant, because I have considered aldehyde and alpha haloester in this case, but you can also consider alpha haloester and ketone, or alpha haloester or formaldehyde, right? Formaldehyde and alpha haloketone you can also consider. So there is no necessity that you for the choosing alpha haloester. In place of alpha haloester you can also use alpha haloketone. Okay, so there are some combination of reactants, but you need to maintain the carbonyl group. that is, the carbonyl group must be present within the molecule, because this carbonyl group is the main integral portion for carrying out the reaction. So up to this, if you have any doubt regarding this topic, then please ask me through the comment section. And if you like this video, then don't forget to hit the bell icon. Thank you.